Problems number 15 and 16 refer to this information, and here they're giving you a graph that displays the total cost, C, in dollars for renting a boat for H hours. And problem 15 says, what does the C-intercept represent in the graph? Well, here is the C-axis. The C-intercept is this point right here, which is the point 0, 5. Normally you're used to seeing a point given as x, y. This particular graph just gives you, as opposed to x and y, h and c. So what does the c-intercept, what does this point 0, 5 represent? Well, basically it's saying after h hours, so 0 hours of renting the boat, the cost, c, is $5. So 0 hours corresponds to $5 cost. So initial cost of the boat, the total number of boats rented, well, it doesn't say anything about total number of boats. The total number of hours, no, it doesn't say total, it just says 0 hours. And the increase in the cost to rent a boat, no, this basically is giving me, answer choice A, the initial cost of renting the boat. So it costs $5 to start this whole process off. Problem 16 says, which of the following represents the relationship between H and C? And you can go about doing this in a lot of different ways, but what I'm going to do is I'm going to just pick a point on the line. In this case, this point right here is the point 4, 17. 4, 17, because that was a point on the graph. I'm just randomly choosing a point on the graph. I'm going to plug in, traditionally, x is 4 and y is 17, except here we're not doing x and y, we're doing h and c. So I'm going to plug in to all 4 of these equations to see which one matches this point. So here when I take answer choice A, c equals 5h, that would mean that c, 17, equals 5h, 5 times 4, and that's not true. 5 times 4 is 20, not 17. Answer choice B, c equals 3/4 h plus 5. Well, c, that's going to be 17 for that point. That equals 3/4 times h, so 3/4 times 4 plus 5. And here, if I do some math, the 2 4s cancel. So I have 3 plus 5 is 8. 8 does not equal 17, so answer choice B is incorrect. I just chose, again, any point on the line. I could have chosen the point, looks like here, this is the point 3, 14. I just happen to choose 4, 17, and I'm testing all the different answer choices. Answer choice C, c equals 3h plus 5. Well, here c is equal to 17. That equals to 3 times h, 3 times 4 plus 5. Yeah, and 12 plus 5 does equal 17. I just want to make sure that answer choice D does not check. Here, answer choice D, h equals 3c. So h, that equals 4, equals 3c, 3 times 17. And 3 times 17 is 51. So that one doesn't check, which means the answer is letter C. Problem 5, which of the following graphs best show a strong negative relationship, strong negative association between D and T? Well, this goes back to geometry. You were taught that lines that go from bottom left to upper right, they have a positive slope, and lines that do the opposite, lines that go from upper left to bottom right, have a negative slope. So basically, I'm looking for points that kind of resemble this pattern going from upper left to bottom right, and it looks like B and C don't represent that. It looks like the best answer there is letter D, because the points kind of represent a line going in that direction. So I'm going to say letter D for this number 5. Problem 14, according to the line of best fit. So that line right there is the best fit line for all these different points that you're given. According to the line of best fit, which of the following best approximates the year in which the number of miles traveled was 550 billion? Well, here's the number of miles traveled. Here's 550 billion. So that appears to be about here, which would correspond to right about there on the year axis, which looks like about 2005 as far as me quickly drawing this thing. So A and B are kind of crossed out. Now, C and D both look like they're going to work. So let's look at this a little bit closer. And if I try to draw my line a little bit more precise, it looks like it's a little closer to the year 2003 than it would be answer choice C. So I'm going to go with letter C for that particular one. For number 27, 2 samples of water of equal mass are heated to 60 degrees Celsius. One sample is poured into an insulated container, and the other sample is poured into a non-insulated container. So it looks like the squares are the insulated and the dots are the non-insulated. The samples are then left for 70 minutes to cool in this room of 25 degrees Celsius. The graph above shows the temperature of each sample at 10-minute intervals. Which of the following statements correctly compares the average rates at which these 2 samples change? Well, here I'm going to have to go letter by letter to see what I have going on. And letter A, in every 10-minute interval, the magnitude of the rate of change of temperature of the insulated sample is greater than that of the non-insulated sample. So you're looking for the rate of change. So for example, if you look at the insulated, from 0 to 10 minutes, the insulated goes from 60, the insulated is the square, 60 down to about, I'm going to say about 51. So the magnitude of the rate of change just means we're looking for a positive number. The change would be 9. So it says in every 10-minute interval, the magnitude for the insulated is greater than that of the non-insulated. Well, look at the non-insulated. At 0 minutes, that's also 60. The non-insulated is down to about 41, 42. So that would mean the non-insulated would have a greater rate of change than the insulated. Letter A says the direct opposite. So letter A is not going to be correct. Letter B, in every 10-minute interval, again, every being the key word here, the magnitude of the rate of change of the non-insulated is greater than the insulated. Well, let's try to find an example of when that's not true. The non-insulated, if you go from minute 50 to minute 60, the non-insulated kind of goes from, I'm going to say, about 27, 26 to pretty much the same. Maybe it goes down by 1. But the insulated in that interval looks like goes from about 35 down to about 32. Now that's close, but that means that it's not true for every 10-minute interval. So letter B is incorrect. Letter C, the intervals from 0 to 10 and from 10 to 20, the rates of change of the temperature of the insulated are greater. So let's see what that means. Well, the insulated, we said from 60 down to 52, so that's about 8. If you compare that to the non-insulated, 60 down to about 42, that's 18. So in intervals from 0 to 10 and 10 to 20, the rates of change of the temperature of the insulated were greater. Actually, that's a contradiction right there. From 0 to 10, the non-insulated was greater. So that one's going to be incorrect. So I'm hoping by process of elimination, here my answer is going to be letter D. From 0 to 10 and from 10 to 20, the non-insulated is greater. Yeah, it looks like from 10 to 20, you go from 42 down to about maybe 33, so that's 9, versus the insulated from about 52 down to about 47, so that's 5. So from 0 to 10, which we checked for letter C, and from 10 to 20, the non-insulated was greater. But when you go from 40 to 50 and then 50 to 60, the insulated is greater. And it looks like, yeah, basically the non-insulated tends to level off here, while the insulated tends to have a drop for each of those intervals. So I'm going to go with letter D for that particular question. For number 20, Michael swam 200 yards on each of 18 days. The scatter plot above shows his swim time and the corresponding heart rate after each swim. The line of best fit is also drawn. This happens a lot in statistics where you have your data and you try to draw a line which represents to the best of the ability what's going on in the graph. So it says, for the swim that took 34 minutes, so the swim that took 34 minutes looks like this one right there. It says Michael's actual heart rate was how many beats less than the rate predicted by the line of best fit. Well, this is the actual point for the 34-minute swim, and his actual heartbeat appears to be, if I'm reading this graph correctly, 148, because it looks like from 140 to 150 there's 5 lines, so each line represents 2, so that would be 142, that would be 144, so it looks like it's actually going to be 148 is the actual, and the question says Michael's actual heart rate was how many beats per minute less than the line of best fit. Well, the line of best fit looks like the point would be right there, which predicts 150 beats per minute. So that's the actual prediction based on the line, and his actual swim was 148. So it looks like here, how many beats less? It's going to be letter B, or 2 beats less. Problem 3, the graph below shows the total number of music album sales in millions each year from 97 to 2009. Based on the graph, which of the following describes the general trend? So we're going to try to read this graph and try to get the general trend. So here we're given years since 1997. So 0 would actually correspond to 1997. So then 1998 would be 1, and 1999 would be 2. So what's the general trend? Well, it looks like it kind of increases a little bit and then starts to slowly decrease. So letter A, sales generally increased each year? No, it increased in the beginning. Sales generally decreased each year? No, it looks like in the beginning there was a slight increase. Then it says letter C, sales increased till about the year 2000. It kind of looks like it increased until about the year 2000 and then generally decreased. So if I had to go with an answer choice, it looks like that's probably the one. Letter D, sales generally remain steady. No, it looks like there was a general negative trend. So that's why here our answer is letter C. Number 12, if the function f has 5 distinct zeros, and here there's a note that says the zeros are the x-intercepts. So for example, if I look at letter A, here's the x-axis. Letter A crosses the x-axis 1, 2, 3, 4 times. So it says if the function f has 5 distinct zeros, meaning it crosses the x-axis or touches the x-axis 5 times, so 5 x-intercepts, which of the following could represent the graph? Well, letter A only crossed the x-axis 4 times, so that's not right. Letter B, here's the x-axis, it crosses 1, 2, 3, 4 times, so that's incorrect. Letter C has 1, 2, 3, 4, 5, 6 x-intercepts. That's not correct because the question is looking for 5. So I'm hoping letter D, 1, 2, 3, looks like it touches the x-axis there, 4, and then 5. So here my answer is letter D. So just remember the zeros are the x-intercepts of the function. So there your answer is letter D. Questions 10 and 11 refer to this information. Here they're given the gestation period, so I guess that's the growth period, versus the actual life expectancy. And a curator at a wildlife society created the scatterplot to estimate the relationship of the gestation period and life expectancies of 10 species of animals. Number 10, which is the life expectancy of years of the animal that has the longest gestation period? Well, here the gestation period is on the bottom axis, I guess the x-axis. So the longest gestation period would be this particular point that I have there in green, right? Because, for example, letter C has a gestation period of about, I don't know, 51, 52 days. Well, here is the longest gestation period, and the question says, what is the life expectancy? So I want to read now the y-intercept there, which appears to be 3. So there, for number 10, the answer is letter A. For number 11, of the labeled points, and it looks like there's 4, A, B, C, and D, which of the following represents the animal for which the ratio of life expectancy to gestation period is the greatest? So I want to find the point where the ratio, or the fraction, for the life expectancy to the gestation period is the greatest. Well, I can kind of set these up. For animal A, the gestation period is about 22 days. Life expectancy is about 7 years. So that's letter A. Letter B, it looks like here we have 44 to 8. So I have 44 on the bottom, 8 up top. For letter C, it looks like I have 51 or 52 on the bottom to a life expectancy of, again, 8. And then letter D, looks like here I'm going to have about 51 or 52 for the gestation period over 10. So I'm looking for the fraction that has the greatest ratio. So I basically want to figure out, of these 4 fractions, which is the greatest in value. So what I did was I entered in these fractions all on my calculator, and which fraction has the greatest value? It looks like letter A, 7 over 12. That has a value of about 0.318. All the others are below 0.2. For problem 15, which of the following scatterplots shows a relationship that is modeled by this equation? And they're telling you that A is a positive number and B is a negative number. So what I'm going to do is just simply choose numbers for A and B and then graph a line and see which of these scatterplots resembles the line that I'm picking. So it says A is positive, so maybe I'll let A be equal to 2 and B is negative. So maybe I'll let B be equal to -5. It doesn't really matter as long as the signs of the numbers that you choose are correct. So here I went into my calculator, I pressed y equals, and I just tried to graph the equation y equals 2x raised to the -5 power. And what I'm going to do is, since all of the graphs given to me are in the first quadrant, they're just graphing the upper right-hand corner of the Cartesian plane for all of these, I pressed the zoom button and I scrolled down to letter A, which stands for zoom, and then graph it in quadrant 1. And now when I choose letter A, here's what my graph looks like. It looks like I have a graph that kind of decreases and then kind of levels off. So which of these scatterplots best represents that? I'm guessing it's letter B. The points kind of go decreasing and then kind of level off. None of the other 3 match that graph. So again, I just chose random numbers for A and B. I graphed it on my calculator to see what that graph would look like. So there, my answer is letter B. For problem 20, the mass of living organisms in a lake is defined to be the biomass of the lake. If the biomass of the lake doubles each year, which of the following graphs could model the biomass? Then they give you a note, 0 corresponds to the point 0, 0. Well, I want the number of organisms to double each year, and letter D is clearly not correct because the graph kind of stays level every year. Now, if you look at point of graphs A and B, both of these things start off at the origin. What does that mean? That means they're starting with 0. And if they're starting with 0 organisms and it doubles each year, that would mean that after 1 year there would also be 0, and 2 years there would also be 0. So these two graphs don't represent a doubling each year. I think it looks like letter C because it starts off with a half. After 1 year it doubles to 1. After 2 years it doubles to 2. So there my answer is going to be answer choice C. For number 21, the bar graph above shows the renewable energy consumption in quadrillions of British thermal units, BTUs, in the United States by energy source for several energy sources in the years 2000 and 2010. And they give you the coloring that represents each year. And the question says, in the scatter plot of the data, where the renewable energy consumption in the year 2000 is plotted along the x-axis, and the renewable energy for 2010, the y-axis, it says how many data points would be above the line y is equal to x. So here they want me to create a scatter plot. They say they want the 2000 value to be along the x-axis and the 2010 the y-axis, and they're saying how many data points would be above the line y equals x. And y equals x is a line that you kind of want to recognize what it looks like. It's basically a line that starts off at the origin and goes off diagonally. So at the point 1 for x, y is also going to be 1. At the point 2 for x, y is also going to be 2. So this red line here represents the line y is equal to 1. Now let's make a scatter plot of what we have going on here. For the biofuels, we're dealing with, in the year 2000, it looks like we're about 0.25, and in the year 2010, we're up to about 1.75. So 0.25, here is that on the 2000 axis. 1.75 is also 2. Is close to 2, so there is that point. That's clearly above the line y equals x. Now for the geothermal, the year 2000, it looks like we're about 0.3, which is about here. And then in 2010, it looks like we're about 0.4 maybe, which is about here. So it looks like that's going to be just slightly above because y is bigger than x. This is the line y is equal to x. Above would be y is bigger than x. Below would be x is bigger than y. So that's going to be slightly above as well. This here for hydroelectric, here you're going to have your x value as greater than your y value because the 2000 bar is taller than the 2010 bar. So if I plot this one, x is going to be bigger than y, so that's going to be underneath. Here, for the wind, the y value, the 2010, is bigger than the x, so that's going to be above. And here for the wood, the x, the 2000, would be bigger than the y, so that's going to be below. So I claim there's going to be 1, 2, 3, or letter C, 3 points above the line y equals x on that scatter plot. B is the form of the equation. Problem 27, the relative housing cost for a U.S. city is defined by this ratio, this fraction. It says you take the average housing cost for the city and compare it, you divide it by the national average housing cost. And here you're given in this problem a scatter plot showing the relative housing cost and the population density for several large cities in 2005. So this gives, with several large cities, the relative housing cost. And you're given this equation, and this equation represents the line of best fit. So this line here has the equation 0.0125x plus 61. And the question is saying, what is the meaning of this 61 in the equation? Here they're giving you the population density, the people per square mile, and the relative housing cost, or the percent of the national average, that population density has. And if we go through our answers, we're looking for the meaning of the number 61 in letter A. In 2005, which is what this problem pertains to, the lowest housing cost was $61 per month. Well, I don't see $61 per month. That's not given to you in this particular diagram. They're giving you population densities, and they're giving you the relative housing cost. So the lowest housing cost isn't even part of this graph. So I think for the first one, letter A makes no sense. In letter B, 2005, the lowest housing cost was about 61% of the highest housing cost. Well, this doesn't compare low housing costs to high housing costs. It compares population density to relative housing costs. So that's why letter B doesn't make any sense either. In letter C, in 2005, even cities with low population densities, so we're dealing with points that are kind of low on the x-axis versus high on the x-axis. Even cities with low population densities were never below 61% of the national average. Well, letter D deals with at least 61%. So at least that's starting to make sense as far as what this 61 is saying. And for this one here, I'm going to say the answer is going to be letter D, and here's why. If letter C was correct, even in cities with low population densities, housing costs were never below 61%. Well, let's say your population density, let's say this line kind of continued here. Letter C can't be correct because if it was never below 61%, let's say the graph kind of continued in this direction. If it was below 61%, you'll be dealing with scatterplot points down here that would have negative population densities. And that doesn't make any sense. Population density is the people per square mile. So I'm going to say for letter D is the answer because even for cities that have low population densities, they're at least 61% of the national average.